Okay, why don't we get started? We've just gone 2 minutes past the hour, and I know there'll be some people joining as we go on. So, want to welcome everybody to, I think this is our 5th season of the networking channel, and we've got a really fabulous kickoff event today to talk about large language models and networking. There's probably not a topic that's generated as much buzz in the computing and technical communities in quite some time. So we've got 5 folks here to tell us their thoughts about that. But before we get going, just a couple things here about logistics. So first of all, the structure of the panel is going to be as follows. We've got our 5 panelists, who I'm going to introduce in a second. They're going to each start with 4 minutes, 5 minutes of their thoughts on large language models and networking, the challenges, the opportunities. That'll take us to about half past the hour, and after that, we'll open things up for questions. So for those of you who are participants in this, welcome. Great to see so many people here. If you have questions or comments, we've got a chat. If you type into the chat, everybody can see that. If you want to have a question or an answer, you can either type it in the chat or you can do it in the Q&A bar that we have. And we have a new feature in our Zoom. We have automatic translation. I'm told if you go to the bottom right-hand side and look at more, and then look at captions, you can enable translation, real-time translation to happen at the time. Okay, so I think that's it. Again, welcome to the first of this season's networking events this is on large language models. And I just want to say a couple quick words about the panelists. So we've got a fabulous group. You see their picture here on the slide. I'll start at the left, and this is the order in which our panelists will be making opening statements. So leading off, we've got Anshu Srivastava, who's a professor at Rice University and CEO and founder of Third AI. Second, we have Elisa Bertino. She's a professor at Purdue University, an expert in security and wireless networking. We have John Crowcroft, University of Cambridge, and also the Turing Institute. He's a professor at Cambridge, and he is a, what was it? A research, John?
Researcher at large.
Researcher at large at the Turing Institute. We have Victor Lee, from the university, a professor at the University of Hong Kong, well-known networking researcher, who's also expanded his research to cover AI and social good. And we have Ajit Patankar, who's a leader in AI and ML in Juniper Networks in Sunnyvale, California. So I want to thank all of our panelists for being with us. It's going to be really great, really interesting. And Anshu, do you want to kick things off? I'm going to stop sharing my screen so you can show some slides, and then once you're done, I'll take it back.
Wonderful. All right. Can you guys hear me? Oh, well, okay. All right. So let's directly jump into the large language model. So I'm not going to take time to explain what are large language models, right? We all know, we all have understood what, we are in what we call post-GPT era. So this is like about 9-10 months where the world have seen ChatGPT. In fact, if you go and ask ChatGPT why, we should care about ChatGPT or enterprises should worry about them, it will itself write some of these answers. And it's very clear that now we are at a point where we can imagine, after all what happened with Alexa, Siri, and, Hey Google, where people were frustrated. Now we can imagine that, look, we can automate a wide range of tasks from customer service, support, content creation, marketing, writing emails, right? I mean, if you look at the collective number of hours we spend on document reviewing, writing emails, formatting, creating tables, creating contents, we believe that a lot of this can be automated to a reasonable extent now, saving, I will imagine, billions of hours in future. And again, and for enterprises, this is great news because, our enterprises always wants to do more. They always want to enhance their businesses. They always want to offer more, and that requires efficiency. And we believe that this tool can help them stay ahead of the curve in an increasingly competitive and again, a data-driven business landscape, right? So now we can imagine that there is a possibility that all the data that we have collected, right? We always used to say data is gold, but now we can start imagining what we could do based on that data. So I think that ChatGPT and LLM has our full attention. What we are seeing in that, and I'll talk more about the challenges in the next slide, but the early use cases for almost all enterprises that we are seeing around is that, look, I mean, I have a lot of domain specialized data. So universities are sitting on, like data, which is about how to onboard a student, hire them, like all the workflow processes, ITs, same for all the enterprises. And some of the early use cases is, can we have a ChatGPT like assistant on these data? And that means that, well, users have much more access to the information. So search is little like, keyword based search. That is all we are used to. I think that is about to change. You can just ask as if you're asking someone. So this is huge. Now talking about challenges, right? I mean, and I think the challenges are too many, right? I mean, remember, we are still in very early stages. And what we are realizing at that, a lot of people, obviously, ChatGPT has caught people's attention, but I think people are still like not clear what are like the real possibilities, right? So the first thing that I will say is that, managing expectations well is something that is some of the challenges, right? I mean, what can ChatGPT do, right? A lot of people think that yes, it is a conversational agent, so conversation is there. Also, there are news about like, look, this is also sort of an AGI. It has reasoning, it has logic. I think we have to be a little careful of what we expect there, right? So like if we expect too complicated reasoning and too complicated things from these LLM models at this stage, I don't think that is right. The other thing is finding the right use cases, right? I mean, now our imagination has blown up. We imagine, oh, you know what? Machines can talk, machines can think, and therefore we can think of like every other use cases around. And I think that is also something that people are finding it challenging, because you think about, okay, let's what will a killer use case be? Let's go and build about it, and then you realize, and it's also part of your management of expectations that, oh no, maybe that's not the right use case, and we need to focus on only one or two things rather than going on a lot of things. Data privacy and data residency is a very big challenge right now. If you want to get the use of these generative AI agents, the way seem like you have to give your data to ChatGPT. And I think this is also the fundamental tension of that these AI agents work on a very sophisticated set of hardware, right? I mean, they require very dedicated, in some sense, supercomputer, like a swarm of GPUs or something to work. And to get data to them, you need data movement, a lot of data movement. So I mean, obviously, data privacy is one issue. If you're giving your data to these AI agents, where they are sitting, how your data is moving, that is something that people need to understand. Data residency is a problem. Look, data movement, and even if it's in your virtual private cloud, you probably are making multiple copies of your data. And that, I think, people need to understand and manage well. I think they should be careful with essentially free services in production, right? And I think we are hearing those conversations quite recently, that people are like, okay, this is great, let's go build this in production. When they start building in production, they think like the first message is, oh, look, creating a demo is very easy. And then you can quickly get started with a demo with the open source tool pretty easily. But the moment you go beyond that, it starts becoming, wait a sec, right? I mean, I'm signing up for this services, I'm putting my data there. That is what is happening. And then when you start to scale up, it becomes a completely different picture. So I think that is what they should be careful about. I mean, we are talking about like some of the challenges. And again, like I will reiterate that by saying that putting a large language model in production is very, very different. And I'll basically present one case study after this. Then making potentially a good demo. So in this current environment with all the open source tool and everything, it's very easy to make a demo, but taking the demo to production is very hard. The popular use case is what we call retrieval augmented generation, and I'll just set the stage in a minute. So basically what the world right now is thinking about building a Gen AI on their data, right? That is a common ask. Now, these Gen AI agents like ChatGPT, I'm showing it in the box here, they don't have a very large, like memory. So think of them as an agent with very small memory. So they cannot understand all your document at this point of time. So what the challenge now is, okay, I still want to use it. So if I am asking a question, let's say, does my organization provide any retirement benefit? And this cannot read all my organization's catalogs or all my organization policies. So maybe only give it the relevant text that will fit in its memory limit or whatever it is, right? I mean, short-term memory, and then we'll generate an answer. So think of it as a conversation where you say that, okay, given this information, can you answer this? It may sound dumb, but this is still a good way to automate. So then now what happens is, okay, how do I get this information now? And then you create two more services. One we call embedding services, another we call vector DB service, right? I mean, just few jargons. Now, what is going on here is now to use this Gen AI agent, you are giving all your data to this embedding services. You are giving all your data to this vector DB service. The problem comes in, obviously, the privacy, data movement, data copy. You're copying your data here because this is a different hardware. Then the same data gets copied here because this is another hardware, and all of your data. The another issue that people are not thinking is the suggestion would be take a small amount of text and convert it into a very high dimensional, what we call embedding. So something like 250 characters to about 1500 to 2000 numbers. And that is the reality of a lot of these retrieval augmented generation systems. You are taking a 500 bytes of text and converting it into like 6,000 to 8,000 bytes of numbers. So you're blowing up your data. The other problem is, no matter how good these models may look like on a small corpus, when you scale, they will make mistakes. So what if the retrieval is not right? Do you go blame a vector DB or do you go blame a embedding model? And how will you fix it? And it seems all of this is just right now a big question mark. I'm telling you, this is what most of the enterprises are facing, and this is what is happening. So the software stack is getting more and more complicated. There are like components being added daily, and they have to be careful. And plus, we all know that these things require very heavy GPUs. GPU weight is right now very real. I mean, even if people start fabricating GPUs right now, they will still take a lead time to even get them. And the rate at which people want, I think the demand is going to be hard. So again, like once you are so imagine an organization, just a high level, and I'll conclude with that. At a very high level, if imagine an organization signing up for this, it may appear initially that all of these are like free managed services, but this is what you are getting into. You're getting into the data, you're locking into GPU, you're relying on a lot of things to work. And if you don't know how this is going, and if you use this in production, you will face all of these problems. So with that, hopefully I've given an overview of that. I will say that this is still like, I'm a professor in computer science. We believe that what we are seeing, a lot of people didn't believe ChatGPT was possible. But there are some very recent results in machine learning, which are kind of telling that there is a lot to uncover. We were underestimating what AI can do, and our understanding has been challenged and changed in a very positive way. So some sort of a photoelectric moment in AI. But this is the first iteration of LLM, and it will refine very quickly. LLMs has all our attention, and I think we will surely give them a full chance to solve some of the the great problems, the potential that it has. And I think efficiency will be the guiding factor here. So that is basically my thought, and I look forward to interacting with you and other panelists on more questions. Thank you.
Okay, that's great, Anshu. We'll come back to some of the questions you raised once we get into the question and discussion period. But Elisa, you're up next. I've got everyone else's slides here in my PowerPoint, so I'm going to share my screen, and you could just tell me how you'd like to have them advanced.
Okay, yeah, I'll tell you next slide already, okay?
Okay.
Okay. So, oh no, you have to go back to the initial one. Okay, thank you. So first of all, glad to be part of this panel. I would like to share you two opportunities, two directions for opportunities of applying a large language model to networks. And one of these directions is related to some actual work that we have been doing using a large language model over the past 2 years. And this first opportunity, let's say, focuses on the analysis of 5G specifications by the standard bodies. Those specifications are really not specifications. They are, detailed descriptions in natural language. And based on our work since 5 years, we found that they often have inconsistencies, under specifications, and many other problems. So our first, and then we can move to next slide. Our first task that we decided really to try on a large language model was, can we find vulnerabilities in the design of those protocols by looking in conflicts from this specification. So the idea that we will look for sentences or text which has a conflict. An example would be that in one part of the standard, you say you have to do this control. In another part of the statement, for example, the idea is that the control is optional, or you have to do the opposite. So we decided to use, again, this language NLP technology. And of course, we had a lot of challenges. So in general, I would say that with any machine learning technology, usually you have to have a complicated pipeline which combines different techniques. But the challenges to start were that these large language models are not domain specific. So to address this problem, we had to do a fine-tuning of many of those large language models, not ChatGPT, but BERT, for example, to make sure that they would understand the 5G language. So we created a large data set of sentences which were used to fine-tune the model. And this data set is publicly available, and some companies already have been using our data set. So this was the first problem. So basically, using our data set, we could pre-train many large language models like BERT and many others. And we found that after pre-training with this data set, they could do a better job in some important tasks. For example, summarizing a portion of the standards, or even finding statements which refer to security properties. Going back to this conflict, this was very complicated because typically, of course, after we pre-trained one of those large language models, we had another important challenge. How do we look for conflict in pairs? Because the standard is very huge, and therefore we cannot compare every sentence with every other sentence. So we had to use generate embedding vectors to encode somehow sentences, and looking at very well-known techniques in information retrieval, looking at frequency of terms appears in these sentences. And then we did the similarity check using the embedding vector, then retraining our model to work on a specific natural language task, which is the Stanford natural language inference, which what this does is kind of a task that the model has to predict if a given pair of sentences entails each other or contradict each other. So with that, we could retrain the model. And since we didn't have annotated data, labeled data, we used an ensemble model to then find the actual conflict. And finally, using those conflicts, we then tried to run sequences of interaction to find if those will really lead to a real vulnerability. So at the end, we want to see if this conflict may really introduce a vulnerabilities in our interaction, in the protocol. So as you can see, basically the bottom line is that you needed to do a lot of work. It's not that you just take a large language model and you apply as it is. So this has been our experience, and which has been very successful, I would say, but required us a lot of work understanding the various technology one can use, but certainly as promised. Now I want to move to next opportunity. This is more general, of interest to, in general, to a lot of people in computer science, the opportunity to generate automatically code. Now, this is particularly important, especially when we move the direction on, for example, open radio access networks and the ability to have a reference implementation where one can augment the code, can provide different implementation. So this is an important area. And there has been a very interesting paper done last year, actually was published, to understand whether this code is correct. So I come from the security area. So for me, understanding whether the code generated as a vulnerabilities is a critical problem. And the initial evaluation done by this group of researchers on the GitHub Copilot has shown that basically this code has a lot of bugs, unfortunately. And of course, this is not a surprise, because basically how this Copilot, so is a very well-known project, how it is trained by collecting software on all GitHub repositories. And of course, this software has a lot of bugs. So you can see the results. They found that 40% of the code that was generated was vulnerable to the top risk vulnerability by MITRE, so the most top 25. Now, in addition to this problem of security, of course, if we were to use this type of technology to generate code for networks, we would need to fine-tune the model to understand network programs, and also to understand for security different bugs which are typical of this type of code. So the bugs that you find in code for different domains may be very different. Like in SQL application, you focus a lot on SQL injection. For networks, you may really focus on other type of bugs, even though injection vulnerabilities also affect programs implementing network protocols. So this is our experience and about some opportunities. So I'll stop here.
Okay, great. I'm a big fan of that NLP work that you've been talking about, at least as you know. So, and I imagine actually that your last slide is going to feed very nicely into some of John Crowcroft's thoughts. Go ahead, John.
Okay. Yes. Well, I've been asked by lots of people to look at LLMs and networks, and they threaten me with money. And three very big companies, I won't say who, their technical people said they thought it was a really crazy idea, but that their bosses were telling them they really needed to look at LLMs. And this reminds me of people being told they have to build a quantum computer, they have to solve cold fusion, they have to do levitation and superconducting at room temperature, and many other things which are all nice little fantasies, but are some ways off. So, and I think the previous speakers have picked up nicely, actually. So I was going to be very contrarian, but I think I'm not so contrarian as I might have seemed. So I've got, like, 4 reasons principally why I think we should not be bothering much with LLMs. As an academic researcher, of course, you can do what you like, that's fine. But if you're in an industry world, you might be thinking this is a distraction. So the first reason is that LLMs are not affordable. We already heard that. They're essentially non-sustainable, not affordable, that the training costs are crazy. I'm talking about LLMs. I'm not talking about, Hugging Face's small language models. I'm talking about the ChatGPTs and Bards and, BERTs and whatever. And we're living in a world where we can't afford computations that cost $4 million for one training iteration. This is completely crazy. In the Turing Institute, that's 4 years of our Azure budget. So, if you're a small company, that doesn't make any sense. So that's the first thing, is they don't scale, they don't sustain, whatever, they're not affordable. The second reason is they're not explainable, and it's unlikely they ever will be explainable. So there was a DARPA program in XAI, which is extremely good, and there's been some very fine outcomes from that. Several techniques are now fairly widespread for explainable AI. They work, or what used to be black box AI systems, like convolutional neural nets, a reasonable scale, things like Shapley values or gradient integration. There are a bunch of these, and they're pretty decent, but they don't scale themselves, but they work on modest systems that are usable for image processing, for recognizing features in an image, for self-driving vehicles or whatever. Those work. But when you take a system with 350 billion dimensions, there's no chance of them working. There's simply no chance. That you take a non-sustainable system and make it much worse. And even in a 100-dimension system, you're looking at a 3x multiplier in a very simple image processing application. So the explainable thing is really important because most networks are critical infrastructure, and we cannot afford to have systems that don't give us explanations about what they're saying. So if you're optimizing your traffic management or you're doing inferencing of what the cause of some failure was, you want to know that you've got, the accuracy is transparently in front of you. And the third thing I was going to say is that we have many techniques that work like that, even at scale. So there's a very nice paper a few years back from China Mobile on using causal inferencing for fault diagnosis in cellular networks. And it's a published work, and it was reproducible, and it worked at scale, and they did a root cause analysis, and they used all the Juniper, beautiful Bayesian stuff that works. We have loads of other techniques that work, and they're affordable and interpretable. You can see why they work, and they work for a wide range of problems. So that's my third thing. And then the fourth thing is it's important to realize that we're in the absolutely maximum hype point of a technology. And unfortunately, people will hype things to get their acquisition values up. So this has nothing to do with the technology. There's not even a bad thing. It's a normal thing. Anyone's done it. I have colleagues who do this. We do a startup and we talk about it and we say how wonderful this technology is. Well, of course you do. That's like part of your salesmanship. There's nothing, evil about it. But unfortunately, this thing has kind of gone a bit too far. And it's a distraction from the things that are out there, small language models, classical NLP techniques, causal inferencing, really simple techniques, which work very well on many, many statistical problems, which is essentially what we're looking at. I think one should weigh in about that distraction. And the distraction particularly problematic at the moment because many areas in the world, including China, Europe, and North America, are seriously considering regulation of AI. And part of this distraction is potentially a regulatory capture. It's an attempt to avoid transparency about how regulation of AI should happen. And that's a very political point, I realize, but I'm able to say it as an academic. I don't work for any of these big companies, but I think this has happened in other domains, and we should worry about it creating too much attention for something where many of the practitioners have working tools that have the right properties, and we're not being offered something that has the right properties. That said, I was fascinated by the last talk because I actually think one of the few areas where LLMs are starting to make people think very hard, and in fact, the previous talk as well, when we put filters before and after, we start to get some insights into the statistics of language models. What is the model? What does it mean? And that will lead to research. So that's why academics should really research this stuff, because we'll get a better understanding. We'll probably throw away almost all of the LLMs, but be left with a new technology, which could be very exciting. In particular, for example, in things like model checking of code and systems and specifications, which are currently written in the internet in natural languages, which really are problematic. And there've been NLP work on that, looking at RFCs as well. But I think now we have some tools that may take us further, and in researching the methods, we may improve those. So I think that's a cool thing for the research community to push on. And luckily, of course, we have some sort of medium scale language models, Llama 2, what have you, which are not so unaffordable and could even admit of some explanation interpretability as well. So that would be for me an opportunity for research, which would then come back to being potentially useful for industry. So that's my take.
Okay, great. Okay, up next, Victor, I've got your slides here, so I'm gonna share my screen again. Floor is yours, Victor.
Okay. So good morning, good evening, good afternoon. So I'm Victor Lee from the University of Hong Kong, and I would like to thank the organizer for inviting me to join this very interesting panel. My talks focus a little bit more on how you make LLMs explainable. That actually try to address what John said earlier. So these are outline what I want to talk about today. Next slide, please. So I'm affiliated with the Hong Kong U AI to Advance Wellbeing Society research platform, which is a research platform that include people from different disciplines. And our mission is AI for social good. So what we want to do is we want to develop and apply AI technologies to important societal problems. For example, one problem we apply to is to use AI for detection and treatment of Alzheimer's disease. Next, please. So there are a number of advantages of LLMs. There's significant increase in performance due to a large model scale. It is a key building block in many traditional natural language processing tasks. And it is actually integrated in the consumer AI facility, facilitate daily routine tasks. So I use it all the time to write reference letters. For example, I give it a few bullet points and it composes a very nice grammatically correct prose for me. Next, please. However, there are limitations, especially if we want to use it for decision making, because as we say, garbage in, garbage out, the model is only as good as what the data you put in. And if the model is trained on data biased towards certain groups of people, then you'll get biased results. Another problem is it tends to hallucinate. It will give answers that sound plausible, but actually are incorrect. In fact, we try to do it for a research problem. It actually gives us, references in the right format with author list, title, journal, a page number, and so on. But if you search for it, it doesn't exist. Another problem is it has unreliable reasoning capabilities, and it gives inconsistent answer depending on the way you ask the question. So that's why we said, oh, well, maybe the next research topic should be how do you engineer the prompt so that you get the answer that you want. Next, please. So can LLMs help network operation decision making? I actually asked this question in ChatGPT. This is I rephrased the answer. So these are the answers. Yes. You can do predictive maintenance, you can do customer service, you can do network optimization, you can do fraud detection, and so on. Okay, but is that satisfactory? Next, please. Can LLMs answer causal questions? Okay, for example, you go into your doctor's office and the doctor said, okay, I'm afraid you have cancer. And you ask, well, why? Why do you have cancer? Well, we don't know, but our chatbot is 99.99% accurate. Okay, you're not going to be very happy about that. Or you ask ChatGPT about a network optimization problem, and it tells you, okay, you need to modify these parameters, and they will optimize the performance. Otherwise, your network is going to fail. Well, why? Well, I'm sorry, I can't tell you, but we are 99.9% accurate. So scale is not everything. First, AI-based models are very good on correlation, but however, it remains very challenging for LLMs to understand the causal relationships. So explain what causes a decision or what causes a human, what a particular outcome. And of course, answering causal question is central in human decision making. Next, please. So this is a very simple causal model. You have different entities, x1, x2, x3, and then an arrow from x to y means that x causes y, and then you want to be able to answer what if kind of questions. If x happens, then y happens, or Well, which variables will have to be different for the outcome to be different? For example, you apply for a loan and you are rejected. Well, you need to know why you were rejected. Oh, well, you were rejected because if your income would have been 20% higher, we would have approved the loan. Okay, so this is an example of a counterfactual explanation. Next, please. So the question is, can we make LLMs causal? Now, the strength of LLMs like ChatGPT is text mining, actually. So if we can use ChatGPT to mine existing networking literature based on well-designed prompts, mind you, then we may potentially find a causal relationship between different network entities. And such findings can then be verified by networking experts. For example, you mine the networking literature and you find that event A will cause event B, but event B will increase the risk of network congestion. Okay, you put all those different entities and arrows, you create something called a causal graph, which, by the way, is a hypothesis. Okay, and based on this hypothesis, then you can see using data to see whether the edges actually are viable. Okay, and then you can begin to answer questions like, oh, I can come up with a network failure detection model. Next, please. So to conclude, AI is a tool to serve humans. So LLMs have advantages and limitations. So we would like to understand how to best use this tool to our advantage, because human beings are unlikely to follow decision without understanding the reason behind the decision. And explainability is an important step toward making AI more useful in decision making. Next, please. So this is our team. Next. John and I were actually organizing a special issue on generative AI for sound decision making, challenges and opportunities. So you guys are welcome to submit to this special issue. Thank you.
Okay. That's great, Victor. I'm sure we're going to come back to a couple of the issues you raised, probably around explainability and causality. And our final panelist comes to us from Juniper Networks. So Ajit, want to give us the view from the inside and a broad view as well?
Yeah, thank you, Jim. First of all, Jim and the rest of the networking channel team really appreciate inviting Juniper Networks to present our view at this forum. It's a great pleasure to be here. Jim, yeah, next slide, please. So let me quickly introduce myself. So I lead the data science AIML team within Juniper Networks CTO organization. So my team's focus is essentially on products and services. Our CTO, Raj Yavatkar, who is a very well-known figure in the networking industry, and Jim, of course, knows him well. He, along with our CEO, Rami, are really putting a lot of efforts, lot of support behind generative AI. So they do see significant benefits, significant value in generative AI. And we view generative AI as a continuation of our work in AIML. Juniper Networks has many products which embed AIML. For example, if you look at Marvis Mist Wi-Fi access point, there is a AIML agent that sits behind the access point that monitors the network conditions, and it is also capable of taking corrective actions. So we have long, history, long kind of, it's in our DNA to apply AIML in challenging networking issues. This slide kind of shows our thinking on where the opportunities are and where the risks are. We view the opportunities in terms of two axes. One is data, whether the data is public or private. And second is the LLM or GI model, can it can we apply a generic model? Can we directly use ChatGPT, or we need to apply a more customized, fine-tuned model, or various practical flavors of that? Pure fine-tuning is not the only option. There are multiple ways in which you can constrain the model towards a particular document snippet or particular context. So towards that goal, we believe that the more challenging opportunities, as well as the more benefits, will be where we have customized models, as well as the models apply on private data. So for example, coding assistant, I will quickly come to that. Then internal as well as external services, marketing, legal. So those would be many of the opportunities that not just networking, but any business can avail because of the generative AI. The risks are also significant. There is financial unpredictability. It is not a simple API-based cost model where you have, you use the API 100,000 times and you get hit with certain bill. Each API call with the number of tokens, that determines your cost. There is content unpredictability. For example, if you are on a Amazon website powered by generative AI, you don't want to be presented with a product or service from Walmart, which might happen if you are using generic ChatGPT services. Next slide, please, Jim. Here are some of the use cases. I'll focus on one or two of these. One is in product enhancements. The day 0, day 1, day 2 operations of a network, can we make these operations easier, or can we do them more productively using generative AI? The answer is yes, it definitely is a possibility, and we'll talk about the risk, or we'll talk about the guardrails going forward. For example, day 0, configuration of the network. Generating the configuration is very tedious, very labor intensive. However, we are not at a stage where we can have generative AI generate a configuration of a network, a router, or a device, and you can just transmit it to your device and get the system up and running. We advocate what is called as human in the loop approach. So you use the generative AI to generate the configuration, but the final decision, the review, has to be done by an expert or an engineer who will review the output and say, hey, this looks good. And to some of the points raised earlier, this is where, if the viewpoint is the glass is half full, that's what is needed. You may not be able to save, all 10 hours of generating configuration, but if you save 5 hours, hey, that's a very worthwhile benefit from a business point of view. Then there are numerous point solutions, numerous internal operational efficiency solutions. For example, legal contract reviews, generating publicly usable content for marketing. So for example, verticalizing the content. You have some content for, say, healthcare industry. You have some content for, say, networking industry. Much of that is very similar. Can we use generative AI to customize it? Yes, of course, you can use that. Next slide, please, Jim. I will not mention the specific tool that this refers to, but we have significant effort underway to use generative AI-based coding assistance in our operation. Juniper Network is essentially a software development company. You know, we have almost 5,000 software engineers in various roles. And naturally, if we can improve the productivity or make the lives of these 5,000 developers easier, you know, that's a huge impact on our operations. So here is a sample data from a pilot program that we ran. This is somewhat anecdotal data. As in any software development process, it is very hard to perform quantitative productivity measurements. But the feedback that we got from developers is the productivity improvement can range from 25 to 60%, depending on a specific type or specific use case. To address a couple of issues, I think one of them was from Elisa. The software development assistants are not a substitute for good software development practices. You know, we have very rigorous testing processes, we have very rigorous quality processes, and we want to ensure that those processes are followed. So for example, a human developer, his or her code can contain security issues. There could be other bugs in it. And of course, you know, just like we deal with any of those issues created by a human software developer, we need to use something like SonarQube or any other static analyzers to analyze the code. And furthermore, the code doesn't go directly into the production. The code, there is directly a human in the loop. The developer reviews it, changes it, modifies it, and of course, then it gets absorbed in the code line. In spite of all those issues, in spite of all the risks, I think this is one area of generative AI that is here to stay. And if there are any organizations which claim they don't use it directly, that might be an official position. But if you ask the developers, I'm sure, you know, on their side, just like they use Stack Overflow or any of those tools, they are using one of these tools. Great, thanks, Jim. Next slide, please. And I will run through it quickly. So these are some of the guiding principles. You know, to the point that John raised, that this is very, very costly. Yes, it is costly. So it is imperative to have, you know, clear business guidelines, clear, you know, kind of like centers of excellence, or, you know, use the resources wisely in this area. Next slide, please. Yeah. To address some of the legal data privacy as well as business policy issues, we have an internal governance framework that analyzes the risk, and it provides guidance both as well as prescriptive, you know, policies when and how generative AI can be applied, whether it's in our internal processes or external facing processes. And some of the key factors there are data privacy. Is it likely that when we send our documents for a fine tuning, they might end up in a public domain? What is the risk of hallucination? Is there a human in the loop? Are there any legal risks? Even for code completion, are we likely to contaminate our code base with open source or proprietary software? So those are the risks that we do take into account, and we are very cognizant of those risks. But nonetheless, our take on this area is there are just such significant benefits or potential benefits that this area will become like essentially all pervading in all networking, or even in fact all business functions. Yeah, thanks, Jim. Yeah.
Okay, wow. Those were amazing presentations. John, you mentioned we should beware that we're at the top of the hype cycle. That's actually not what I heard from everybody here. I heard a lot of caution and some reservations, although Ajit, I think you're looking to the future, you're pretty gung-ho on that. So let me just quickly summarize a couple things that I think I heard across that were common across everybody, and then maybe I'll see if anybody has any remarks, and we can take a couple questions here. So first of all, okay, for internal use, definitely with use with a human expert, a human in the loop, but far from production that you're going to put out there. I think, Anshu, you talked about that everybody wants it out in production, but we're really far away from that. I heard multiple people saying, gee, in a narrowly defined domain where it's specifically tuned for that environment, this is a possibility. So the 3GPP models that Elisa talked about, and Ajit, I love that graph where you're going up to the top right-hand quadrant, and on the x-axis, I think it was, that was really about, customization and private data. So a lot of specialization there, a lot of narrowness, if you will. I heard explainability and causation come up again, or causality come up again and again. And then finally, it sounded like people are most bullish on Copilot and coding assistance, modulo the issues that you brought up, Ajit, about the dangers of incorporating open source and things like that. But the productivity numbers that you cited, 20 to 60%, whenever you can boost productivity like that internally, and it's just one of a suite of tools that people will be using. So I don't know, were you folks, was anybody there surprised at the level of, I don't know, caution or reservations?
Yeah, Jim, one thing I didn't address was the explainability, and I have to give full credit to Professor John and others. That is one area where we are still lagging, although we are engineers, and we try to find ways around it. So for example, in document retrieval, one of the ways that is very common is to use LLM in conjunction with RAGs to get relevant snippets of the documents and show them as a part of the overall output. So that is like, you can say it's poor man's explainability where the answers come from. But I would like to learn from others on the panel if there are better solutions, what's happening in the research. So that is definitely one area I would say it's we need more research for sure.
So let me bring up one question that's been raised here, and that has to do with sort of, I don't know, automated configure. I mean, taking the human out of the loop, right? And so several times we heard people say, oh, humans need to be in the loop. With intent-based networking, you know, a goal where a direction we may be heading, network configuration checking, those kinds of things. These are all about automated tools. And I hear people saying, what? Humans need to be in the loop. Comments? That was a question had been posed.
So, I mean, even if you look at like some of the best applications of AI, so look at like, I mean, again, LLM is like an evolution of AI. If you look at the best AI systems out there that is in production, right? The search engines, for example, right? Recommendation systems. They all are being constantly refined and fine-tuned with human feedback. It's not like, so there is an implicit feedback, but they are. I think the biggest, revelation that people need to have right now is we don't know of a single AI system that is in production and that is not being constantly refined.
Monitored and refined.
Yeah.
Right.
So basically, the way the picture has been painted with this large language model is like, look, they don't need any assistant, or they don't need a lot of shepherding. Deploy it and it will work. Maybe it will work on day 1, definitely not on day 10.
Yeah,
right?
Oh, sorry.
Please go ahead. I mean, I'll just take one
more.
more.
Actually, yeah, go ahead.
So basically, even like if you look at systems like Amazon search, Google search, they retrain again, like, and there is no fine tuning. I mean, I know the world is high on just the fine tuning. There is no fine tuning. It's all retraining. They retrain models every 2-3 days. And that is the reality why those systems are usable. I mean, even ChatGPT is being constantly fine-tuned and hammered as we speak. So if we are hoping that, okay, somebody will give me a system and that will not need feedback loop, that will not need constant monitoring, that we not need constant hammering, I don't know what we are talking about.
Yeah, can I add a comment? Actually, this is very well known. Indeed, today, very high-paying jobs are called the AI whisperer. People will shepherd the AI, you know, and do this. But I have a different, more longer-term question, perhaps to John. Could we in the future having some AI which will monitor other AI? Can provide explanation, because explainability also is very sophisticated. You have a general explainability of the model. Specific cases, why my loan was denied. This is so there are a lot of different types of explanation. I'd like to have an assistant which will provide me the explanation I need. And this can be based on other AI. That's what I think. I don't know, John, what is your view on this perspective?
Well, I think that's a viable approach for some problem areas. Certainly, the thing we do in some of the AI work we do is called physics ML, where PhiML, where you actually have two models. You have a first principles physics model of a system, but you can't solve it precisely. You have to do numerical solutions, and you tune the accuracy of the numerical solution using a data-driven machine learned model. And then you tune the precision of the sense data used to build the data-driven model from the physics model, and the joint system actually is extremely efficient. The physics model also gives you the explainability, but that's a rate. But that only works in systems where you actually have a first principles physics description. So we use this for weather systems, turbulent flow in jet engines, and there's a bunch of nice problem spaces. But I think you can use the same principle of having a second system observe the first system, and also it allows you to do different kinds of interpretation for different audiences. Who needs the explanation? If it's the engineer wants to find the fault, that's different than the customer who wants to be told why their insurance claim is not valid or whatever. So the explainers for chatbots in banking and insurance can be quite straightforward, and actually they're really just expert systems. They're 40-year-old techniques, which are quite straightforward. But they could be talking to another system which is quite sophisticated statistically, but you can combine that. So I think that's a good answer. I think the human in the loop is also an example from the UN. They have a refugee system for dealing with people crossing borders, where they built a llama-based model of all the immigration law for 4 countries in multiple languages, including Swahili, I can't remember, Ethiopian, Farsi, and so on. And they were able to offer simplified legal advice. And this is consistent with the people talking about the legal marketing, or in terms and conditions, or interface learning about how your router config works. Perhaps not doing the critical bit, but learning it. So I think there are questions in that space.
Jim, one quick point I would like to make is, if you are developing a very specific networking application, day 0, day 1, day 2, LLMs are not the only solution, or they are not the main solution for, say, day 1, day 2, where you are collecting telemetry data from your routers, switches, servers. It needs to be analyzed in a more traditional AI/ML fashion. Simple time series, anomaly detection, forecasting, those are the techniques. And on top of those, you can put a LLM type of solution, NLP solution, which gives the user a window into the alerts, events that gets generated. So the traditional AI/ML, if I can call it traditional, and LLMs, they are complementary. They are not mutually exclusive.
Okay, great. God, I'd like to really continue the discussion, but we're running past the hour already. So I'm going to remind everybody that the discussion can and will continue on our Slack channel. The Slack channel is posted in the chat over on the right-hand side. So with that, actually, before I thank the panelists, I want to remind everybody, let me share my screen here. Just 1 second. I want to remind us about what's coming up next, and then I'm going to give my great thanks to everybody. I want to remind everybody that the networking channel continues again in 2 weeks, and we have Henning Schultzren and some of the participants from a May 2023 Dogstool seminar about reflecting on lessons learned from 20 years, 40 plus years, sorry, of the internet. And that promises to be really super interesting as well. So with that, let me thank the panelists. Wow, it was really, really great. We're recording this. There's a lot of things to listen to again and think about it, but I really want to thank everybody for their time, lending their expertise, and for being here. And we'll see you all in 2 weeks.
Okay,
Bye-bye.
bye.
Thank you all.
Thanks for
Thanks.
having
Thank you again.
Bye.
Bye. Thanks.